Welcome to Mzanzu Numerics. Today we'll be going through 3 years of electricity, starting with the November 2023 question paper, and then we'll go to the 2024 and then 2025. So, without wasting any time, let's go to the November 2023 question paper. So, question 8. The circuit diagram below shows a battery with an EMF of 12 volts and an internal resistance of 5 ohms connected to 3 resistor, a light bulb, a switch, an ammeter, connecting wires, and the ammeter and the connecting wires have negligible resistance. So let's name Ohm's law, question 1, question 8, 8.1. So what is Ohm's law? Ohm's law, the first thing that must come to your mind is the formula in which the definition is derived. So this is the formula: V equals to IR. So what can we know from this formula is that because a resistance of a resistor is constant, it means that when the current of that resistor increases, the voltage will also do what? Will also increases, because for the voltage to increase, it depends on the current, because this one is constant for a resistor. And also when the current decreases, the voltage will also decreases. So what does it say in theory? It says that the potential difference across a conductor is directly proportional to the current passing through that conductor, provided what the temperature remains constant. So it's just saying that the potential difference is directly proportional to what? To the current, provided the temperature remains constant. So that's what that's how we define the first one. So yes, the second one. So it says that calculate the total external resistance of the circuit. So the total external resistance of the circuit is not difficult. You have to know your formulas to say that when you calculate a resistance in parallel, is gonna be only if it is two resistor. You're gonna say R1 R times R2 over R1 plus R2. If you would wanna do it a way when there is two resistor or there's more than two, you can either say 1 over R1 plus 1 over R2, and then it will continue like this. So that's the formula. And also when it comes to the one in series, we just add them right away. We just say R1 plus R2 plus R3, and then you'll get your marks when you do what? When you write your formula. So this appears the same in the formula sheet. I think I've pasted the formula sheet this side. Let me check. Yeah, here's our formula sheet. So it's same applies in the formula sheet. You'll see them here located in the formula sheet. You'll just copy them from the formula sheet, and then you'll return them there. So I always have my formula sheet on the side, just in case I will need it. So after we have written down the formula, now let's go back to the question in hand, which wants us to calculate the total external resistance. You must note that when they say total external, we must exclude this one, because this one is called what? The internal resistance is the the small r. So that's why we don't include it here. So we are going to include this one. We are also going to include this one, and this one. You must note one thing here. An important thing that you have to do in electricity is to be able to group resistors. You must be able to group resistors. When you check this resistor and this resistor are in parallel towards one another. They are in parallel towards one another. So we must start with them and say what? RP equals to we're gonna substitute in this formula and say 10 times 10 over 10 plus 10. So it's 5. So it's gonna give us 5. So, and then we must be able to group resistor. What did I mean when I say group resistor? You must know that here we have a various parallel branches. This one is parallel to this one, and also this whole branch which exits this side is parallel with this whole branch. So we must be careful. And what you must know is that this one is connected in series in relevance to this one is connected to series. It means that this one, because we have already calculated its total resistance, we must treat it as one resistor, which means here we are going to write what? 5 ohms. So we are going to write 5 ohms for this whole two resistors connected in what? In parallel. And then we are going to treat it as one resistor, because we are learning on how to do what? Group resistors. So when we add 5 plus 15, why am I adding? Is because they are connected in series in regards to one another, because we are treating them as what? We are treating them as resistors, like, which are like this, 5 ohms, and then that 5 ohms continues with this bulb, which is what? 10 ohms. So we are treating them like this, and then they are going to connect with to parallel to this one, which is R3, which is what? 15 ohms. So we have what? Learned to group resistor. So that's why we are adding this one series in series. So we are going to say R equals to what? Equals to, we are going to add them in this fashion. We're going to add them in this fashion because what? They are in series in regards to one another. So we are going to add them in a straight line. 5 plus 10 equals to what? 15 ohms. So we must count the result that we are done with. We are done with this one. We are done with this one, and we are left with which one? Only this one. So how do we add that one? So one thing we learned is that we must learn to group resistors. So this whole resistor, we are taking it as one resistor now, because we are learning to do what? To group resistor. It's 15 ohms. We have calculated all these resistors together. So when we have grouped them, the final thing will look like this. The one on the top, total resistance on the top plus the total resistance in the bottom is going to be what? 15 and 15. That's how it's going to be. So we have learned to group resistor. Why is it important to group these resistors like this? Is because so that we can know that the sum of this, you have to do it parallel to this one, which means that this 15, you're going to do it parallel when you add it to R3. Let's do it now in practice. So we're going to say R total now. R external, because it's all the total external resistance. We're gonna add it like this because they are parallel in relevant to one another. As I said from the beginning, that this branch is parallel to this whole branch. So let's do it. We'll say 15 times 15 over 15 times 15. So plus 15. So one way that you can learn to get around with things, you must always know that if you are adding similar resistor like this, it will give you half. If you are adding similar resistors like this, it will give you half. So that's why, without even using my calculator, I was able to know that no, half of 15 is what? 7.5. But yeah, it's one of those things. So now we get our total external resistance as what? As 7.5. Now, okay, let's go to the second one. Of course, because they are like this, there are other ways that you can use to group them, but this is the way that I find it simple. There is a way that you can do it all of them together in one equation, but I see that as complicated. So let me write my answers here so that I can rub, so that I can have space. Let me just select, or let me first write my answers before I rub. So here we got a 7. Let me first rub here that we're grouping resistors, 7.5 ohms. So that's our first answer. Now that we have found our 7.5 ohms, we can rub here and work. Okay, there's still some left. Oh, the problem is that after I circle, I touch the thing again. Okay, so let's do with it. 8.2.2, reading of the ammeter. I think I should also simplify my diagram here. Simplify my diagram. Now, what's the reading of the ammeter? So where is our ammeter? Here, our ammeter. So the reading of our ammeter, we must always remember the formula sheet. I have the formula sheet this side. I have the formula sheet this side. You must always remember the formula sheet. That's why I took the section for what? For electricity. The formula that we're gonna use to find the that we're gonna use to find the current is this one. So let's go to see how we are going to apply that very same equation. Also, you when you work, if you don't know the formulas by head, you should work with the formula sheet nearby so that you can know which formula are you gonna use. So how did I know which formula to use? The first thing, I checked at the information. What are we given in the information? We are given the EMF. Okay, that's the EMF. And then what else do we have? We have the R external. This R means R external is the one that we just calculated. We got 7.5. And then what does this R stand for? We say that the small r here stand for what? Internal resistance is 0.5. What are we left with? The current. So that's how we are going to find the current. We must note that this one deals with the total things of the circuit. For example, the EMF is the maximum work done. So this total, and the I represent the I total, and the R plus R just represents meaning R total, because it R total consists of what? R external and plus what? R internal. So it's R total. So when you use the value of R total and use the value of the maximum work done or the EMF, you will get the I total. How do I know that this current passing through here is the total current? Because current moves here and comes and be divided here and comes and be divided, and all the current that moves through this side come to be joined here. They come to be joined here. They separate here, and then they come to be joined here. Sometimes I might find that I am pointing here with this pointer, but this pointer I'm using now is not visible in the final video. So apologies if it is not video visible, this pointer. So when we are using R total and a maximum potential difference to find the I total. So let's substitute 12, and then the I total, we are looking for it, and then the R total is the one that we found. It will consist of R external, which is 7.5, and I internal, which is 0.5, and then it will give us what? It will give us 12, and then it will be I 8. This is 8, and then let's divide 8 by 12 by 8. It's 1.5. So the total current of this external circuit is what? Is 1.5 amperes. So here it's 1.5. So let me write my answer here, 1.5 amperes, so that I can rub. Okay, let me rub here. So okay, then it said the power dissipated in R3. So there are many formulas of calculating power. So the one that I like to use is the one in which I'm given values. There are many equations that you can use to calculate power. Let's go to the formula sheet really fast. So these are all the equations that you can use to calculate power. So you can see or by the vast number of equations, there are many ways to find the power. But the best way is the one in which it will not take you time. So let's check which one, what do we have? We are calculating the power of R3. What do we have? We have the resistor. It means that we must use the formula with R of 15 ohms. Now it's either we are left with only the voltage, or we are left with only the current. Let's check which one can we find first between the voltage and the current. Let's check the voltage first. I think the one that we can find easily and fast is the voltage, although we can also find the current. But the current, I think it will take time. But okay, let's use the one that uses the voltage. What we are gonna do now at 8.2.3 is to first know that the EMF consists of V external and what plus V internal. So it means that the V to the external circuit, it means that will be the V of this branch and the V of this branch. It means that if we find the V external, we'll be able to find this V, and then we substitute because we have R. Let's see, Uri. I think the one that has a V and R is the one that said V squared over R. Let me confirm it in the formula sheet. Power equals to V squared over R. Yes, is the one that uses the V. So it means now we are only left with the V external, because this one we have it, the resistor we have it is 50, the resistance we have it is 15, and then the one for V squared R, we are going to look for it. But it is simple to find this one. Why is it simple? Is because we have our EMF. Let me bring this equation here. Our EMF is 12, and then our V external, we are looking for it, and then plus this V internal. V internal is V equals to IR, and then we must know, because we are dealing with internal resistance, the R will be the small r, and then this we are dealing with the internal resistance, the voltage which is made to overcome the resistance inside the cell, which is made by this small resistor. So we this small resistor gets all the current, because it gets the undivided current when it passes through here, and then the R is the small resistance, which is 0.5, and then this multiplied by this 1.5, or it's just half of this, which is just 0.75. I didn't have to calculate that one. So here's our, it's voltage, it's volts. So because we have find our V internal, it's 0.75, and then we are just gonna subtract now and say V external equals to 12 minus 0.75 is 75, not 55, and then it's gonna be 11.25 volts. So now we are just gonna substitute it here, because when we see that a resistors connected in what, in parallel, why am I treating this as one branch and this as one branch? Is because we have agreed all at the beginning that we can combine resistor. As long as there's one branch and this one branch, all this inside will be seen as one resistor. All these inside are, they are gonna share the same volts, which are 11.25, and then this one also, because it is in one branch, is gonna share 11.25, because the resistors connected in parallel do what, they share the voltage. No, they do not share the voltage, they have the same voltage. So because the V external here from the cell, is what, is 11.25, and then it means that here this branch and this branch will have 11.25. So we come and put 11.25 here, and then we simplify it and say, let me press my calculator. Okay, I got 8.44 watts. So that's the power. So let me write it here, 8.44 watts. And then let me just rub all this, because it's a lot of things which I don't think we are gonna need them, because they're just tweaking when you go forward. So let me also rub here. Okay, so now here's the interesting part now, when they start removing resistors. So let's read. Switch S is now opened. They opened this switch, meaning this bulb is not working. And then the resistance of the light bulb remains. If the resistance of the light bulb remains constant, how will the brightness of the bulb be affected? Choose increase, decrease, or remains the same. Explain your answer. So Let's see. Mm, now they removed this one. First, before you do any conclusion, you must know that you must know that what happens to the total resistance when you remove a resistor in parallel. So this is the theory that we must know. That, let me write it on the side. It's not the answer. Let me maybe write it down here to say that when we add resistors in what resistors in parallel, the total resistance R total does what? R total decreases. When we add resistors in series, R total increases. And then that's the theory you have to know. You have to know that theory. So now we have removed this resistor in what? In parallel, meaning that the resistance is going to do what? To increase. You can practice it. We can verify it. That time, when we had calculated the resistance of this branch, we had found this total to be what? To be 5, and 5 plus 10, and then it's gonna be what? It's gonna be 15. Meaning that because this one is gone here, we are gonna have 15 external resistance R external. But remember that when you calculate our total R external, when this one was still here, how much did we get? 7.5. It means that now total resistance increased from what? 7.5 to what? To 15. Because what? Because if we add resistors in parallel, total resistance does what? Decreases, which means that is the opposite now. When we remove resistors in parallel, it means total resistance does what? R total does what? It increases. Now it increased from 7.5 to 15, and then it will be the opposite with this one also. That's the theory you have to know. So now I'm just a analyzing what happened. The first thing that we have to know is the what? Is that the total resistance increase. A total resistance does what? Yeah, it increases. So there is more resistance now. It means that the current will be low now. It means that the total current will also what? A decrease. So now let's see. Let's see, Ori, how does this affect everything? So one thing that you have to note now is that uh, the brightness of a bulb depends on the power. If you calculate the power to be higher than the power that you found initially, it means that now that a bulb is brighter. So we established that the formula that we're using to calculate power equals to V squared R, equals to V squared R. So now the way that we are going to solve this is, because R is constant of this bulb, we are going to see, how did V change? How did V external change? If we find that V external increased, it means that we'll find a greater power, which will lead us to say that the brightness of the bulb increased. If we find V external to be lower, we'll find a lower power. So how do we find V external? So it's simple. We come to the battery itself. In the battery, what we are gonna know is that because the total current decreased, and then V internal, or or internal voltage, equals to IR. Because V internal equals to IR, this will tell us that because the total current has decreased, it will cause the V internal to decrease. Another statement that is very much important is that the internal voltage decrease. That's a very that's an important a, a concept. And how does the decrease the decrement of the internal voltage have on the V external? We must know that EMF equals to what? V internal plus V external. To say that because EMF is constant, is the maximum work done by the battery. It means that if this one, if this one decreases, to keep the same EMF, this one has to increase. For example, let's say we V external. I'm making V external substitute the formula now, minus V internal. If this one decreases, it means that to achieve the same EMF, now the V internal is removing less from the EMF to get more external voltage. So it means that the V external is going to what? Increase. And when the V external increases, it means that when we calculate it here, we are going to get more power than the one we are going to get initially, because R is constant. It means that now, therefore, power increase. So these are the what? This one. These are the reasons. Note that the first question needs increase, remain the same, or decrease. We have reasoned that this will do what we this we have reasoned that this is going to increase due to the increment in what? External voltage. So now let's write it nicely in this 8.3.2 to say that the total resistance of the circuit does what? Increase. How does it increase? Because we are removing resistors in parallel. And then the second statement is that total current decrease. How does the total current decrease? Because current is inversely proportional to what? The resistance. When there is more resistance, there is less current. And then the last third reason is that now the V internal decreases. How does the V internal decreases? Is because V equals to IR. If now there is less a current which is multiplying IR here, it means that what? The voltage will also decrease. And then the decrease in the V internal will lead to more V external. V external increase. Therefore, if V external increase, it means that the power increase. And what a very important statement that you must not leave is that a brightness depends on power. Now that's how we answer it. I know raise 3 marks. It means that maybe they will choose some of these. Yeah, so that's the 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 theory around that. Yeah, thank you for watching. I notice already the video is long. I'll continue with the following parts in the next videos. I'll do part 1, part 2, part 3.